Solution and complete post-mortem of this cubic equation is on its way. Here we go. Let me zoom in. If R1, R2 and R3 are the roots of this cubic equation, 2x cube minus 3x square plus kx minus 1 equals to 0. Find constant k if sum of the two roots is 1. Wonderful. Let me write this equation again. How many roots is it going to have? Sir, 3 roots, as it is a cubic equation. So they have been named as R1, R2 and R3. One more thing. There is a relationship which has been given in the problem. And that says that sum of the two roots, let's say R1 and R2 have been given as 1. Okay. Now you need to apply all the logic here. Whenever you deal with 3 roots, there are going to be as many as 3 relationships between the roots. Okay. That means you can frame as many as 3 equations. This is something that you already know. Let me show that to you again. Right. These are the relationships that I'm going to be using now. Okay. Wonderful. Sum of the roots. Alpha plus beta plus gamma, that is R1 plus R2 plus R3. When you apply sum of the roots, first of all, let me start negative, positive and negative. I want to apply the sum of the roots concept. So it is going to be negative of negative 3 and divided by 2. So R1 plus R2 plus R3 is equal to negative of negative 3 by 2. Wonderful. Now, sir, R1 plus R2 is already known to us. It has been given in the problem. Just plug in the value. And now you can simply solve for R3. R3 will be equal to 1 by 2 or 0.5. Understood, sir. What's next? Okay. In the next step, we are going to go for sum of the product of the root. Taken 2 at a time. That means alpha beta plus beta gamma plus gamma alpha. Okay. R1 R2 plus R2 R3 and so on. There you have to go for plus of plus x divided by 2. Let me write this. Wonderful. Okay. Now, so we can observe that this R3 can be taken as common. When you do that, you will have R2 plus R1 inside the bracket. R2 plus R1, sir, is equal to 1. We know that. So here, plug in the value as 1. Again, you get a relationship. Now, you have to go for product of the roots. When you go for product of the roots, you have to use this. Minus of minus 1. Let me do that. Alpha, beta, gamma. R1, R2, R3 is equal to minus of minus 1 divided by 2 again. Here it is. So what can we do now? What you can do now is that you can plug in the value of R3. R3 is 1 by 2. So put it over here. R1, R2 will be equal to, let me write this. Here we go. Now what, sir? You have got 1, 2, 3 and one more, 4 equations. Okay. And there are 4 unknowns. R1, R2, R3 and K. So that is sufficient. Let me make some more space. And now let us start with equation number 2. If you watch, R1, R2 is already known to us. It's equal to 1. Let me write it over here. Similarly, R3 is also known to us from equation 1. It is 1 by 2. Let me plug in the values. And now you can simply solve for K. K will be equal to 3. Okay. And now let me erase all the things and let me put this value of K as 3 and rewrite my entire equation. So this is the equation that we were looking forward to. Okay. And this was the value of K. But sir, as far as this problem is concerned, this is a cubic equation. If it is a cubic equation, it should have 3 roots. And as far as we can see, there is only 1 root that we've been able to obtain. What about the other 2 roots? Can we observe them? Yes, we surely can. One sec. I want all of you to take a look at this. This is the graph of 2x cube minus 3x square plus kx minus 1. So if I vary k, the graph is going to change. Watch how the graph changes. The moment I keep the value of k as 3, see, this is what we are interested in. And if you watch, the root, this graph actually cuts the x-axis at only 1 point. And that point is x is equal to 0.5. And this value is something that we've already achieved. Okay. 1 by 2, that is 0.5. Sir, what about the other 2 roots? Where can we see them? Well, the other 2 roots happen to be imaginary. You cannot see those roots on this real number line. Okay. If you want to calculate it, we surely can. Let me go to the next slide. I've written down everything, the original equation. I've plugged in the value of k. and this is R3. R3 happens to be 0.5 or half. Let me do a complete post-mortem. What we'll do now to calculate the other two roots, and by the way, the solution that you're about to see now is not a part of the problem. This has not been asked in the equation. This is just a curious man inside me which wants me to do certain things. Okay, if you are also curious about mathematics, about learning the nuances of mathematics, so do watch it from here also. Otherwise you can stop, right? It's up to you. Anyway, let's apply synthetic division. 2 minus 3 plus 3 and minus 1. Let me write it like this. What is the root, sir? The root happens to be 0.5. Okay, so what we are basically doing is we are dividing this by x minus 1 by 2. When I say x minus 1 by 2, you can also write it as x minus 0.5. So this is going to, sir, perfectly divide or exactly divide. Leaving remainder is equal to 0. Is that true? Yes, it is. Watch. Bring this 2 downwards. 0.5 times of 2 is 1. Minus 3 plus 1 is minus 2. 0.5 times of minus 2 is again minus 1. Minus 3 minus, this is plus 3. Minus 1 is 2. 0.5 into 2 is 1. So minus 1 plus 1 becomes 0. Now, we started with a cubic equation. That's a cubic equation. And now you're going to end up with a quadratic one. So this is going to be 2x square minus 2x plus 2 equals to 0. This is how you need to write it. Factor it. Done. This entire stuff, this entire expression can be written in this form. So this is the real part. This becomes the imaginary part. You can say so. Okay. This is going to lead you to the real root and this is going to lead you to the imaginary root. Why am I saying so? The reason being very simple. If you watch here, the roots can be calculated using minus b plus minus under root of discriminant, that is b square minus 4ac over 2a. You can actually use this formula. When you plug in all of these values, this is what you get. If you take the positive sign, x works out as 1 over 2 plus under root of minus 3 by 2. Well, this can also be said to be r1, whereas r2 is equal to this much. When you take the sum of these two roots, r1 plus r2, one thing that you all must realize is plus under root of minus 3 by 2 and this minus under root of minus 3 by 2, these two cancel each other out and half plus half becomes 1. And this was given in the equation, that the sum of the two roots happens to be 1. By the way, in the question, nowhere it was written that the sum of the two imaginary roots is going to be 1. This is something that we worked out and I congratulate all of you. So that was all from my side for today. If you really appreciate the content, do like the video, share it with your friends, subscribe to the channel and press the bell icon so that you receive all the future updates. Thank you very much. This is Manas Patnaik signing off. Take care.